to start off with today's notes. They're vector applications. We're still talking about vectors. And before I start, though, I want to remind you of a concept we've already studied, because we're going to need it today. Okay? And you don't have to write this down. I just want to show you this really quick. Remember when I would give you a triangle, and if I told you that this was 38 degrees, and that this was 8, and this was 10, if I was going to ask you for this length, do you remember what we would use? Law of what? Cosine. Law of cosine. And the way I know that, remember if you have an angle and the two sides are together, or I would kind of show you sometimes, okay, they're all wrapped around together to see. Okay, so if you have an angle and two sides touching, you can use law of cosine. And the way we did that is these go together. So I would say to you, all right, I know x squared, because that's what I'm looking for, equals, now use the two sides, 8 squared plus 10 squared, minus 2 times 8 times 10. Do you remember what the next part would be? Cosine of my, I used x here, so what am I going to use there? 38 degrees. Now use your calculator really quickly to find that answer. You want to be sure your calculator's in degrees, and you're going to type just this part in your answer into your calculator. When you get the answer, it's going to be really big, because what are you going to have to do to your answer? Take the square root. So in other words, you're going to get x squared, and you're going to get some answer here. And to get the actual answer, you take the square root of it. So x equals, what did you guys get for the value? Thank you, 6.15. So this side is about 6. Okay, so that's just something you already needed to know. So we'll move on. Okay, we're going to talk about airplane traveling and things like that. The first thing I want to talk about is that everything we do, we are going to use, angles are always going to be named from due north. So right at the top, angles always go from due north. Okay, and the other thing I want to remind you of is that we talked about earlier, magnitude is the same thing as what? What two things do we call magnitude also? Magnitude equals speed, excellent, which also equals length. So if you're looking for the length of something, it's the same as its speed. Because guys, you can find out how fast something is going if you know where it started, and you know where it ended, and you know its time, you can find its speed, right? Distance equals rate times time, right? That's something we studied a while back. So length is the same as speed. That's important to know. Now the next thing is more conceptual, so I just want to talk to you for just a second. And the reason that we have to call angles from due north, and this is the reason why. Okay, I'm going to draw a grid right here, and this is not like a coordinate plane. This is the compass rose. In other words, for example, this is north, south, right, west and east. Okay. If I'm talking about direction, and I have an airplane, right, and when an airplane takes off, let's say that they're on a runway, and their runway is facing east. Okay, when they take off, they want to take off just right here, this direction, kind of going this way 10 degrees. When it wants to call now, someone asked me earlier, and so I'm glad that they spoke this. They're like, what do you mean? An airplane can't go underground. No. This is not the coordinate plane, right? This is just direction, okay? So I've got this airplane trying to travel east, and it's going to go a little bit to the right, which means it's going kind of, southeast, okay? So it's going down, or this direction, okay? And here's the problem. When people try to talk to like a radio control tower, and they say, hey, I'm facing east, and I want to go 10 degrees towards the south, it's very confusing. So what they do is they take every single direction of the whole compass rose, which would be 360 degrees, right? And they just say from the north. So if you were going to guess, if you were going to call the radio tower and say, okay, I'm going to go whatever degrees, which direction you're traveling, how many degrees is it from north? How many do you think that would be? What? Yeah, it's 100. And if you aren't seeing that, then let me show you what I mean by that. Okay, if you were traveling due north, that would kind of represent 0, right? So if we're going to go from here all the way to this piece, then east is 90 degrees, and we're going to go 10 degrees a little bit more. So I would tell the air traffic control, I'm going to go, whatever miles per hour at 100 degrees. Okay, and in that way, I've got a direction, and everybody's the same. Not 10 degrees from the south, or 50 degrees from the north, or whatever. It's just the same. You don't have to worry. Everything's done from the north. All right. Okay, so that's the purpose of that. Now then, that you understand that, we are going to draw a picture of a plane. And we're going to draw the same compass rose. It is not a coordinate grid. I know we've been drawing coordinate grids forever, but this one doesn't count as that. So the first step is to give yourself a little map, okay? And consider this the compass rose. It is not very straight. You do a good job of making it straight, but okay. It says a plane is traveling west at 700 miles per hour. And if you know the speed, you also know the length. That's what that's saying. So I'm going to travel west. Well, that's easy, okay? If I'm at the center of something and I'm going to travel west, which way am I going to go? To the right. So with a kind of a thick line, draw your airplane. Here it is. Okay, and the distance is 700 because speed is the same as length. Okay. Now, in real life, there's always a wind, correct? There's always wind. And wind is going to affect an airplane. Does wind slow you down or speed you up?
Depends on the direction you're going.
Very good. It depends. If it's a tailwind, you're going to go faster. If it's a headwind, you're going to go slower, right? If you're running into the wind, it's harder. If you're running with the wind, it's easier, right? Okay? So then there's always wind. So we're going to the point of that is we're going to have to take that into consideration. Okay? And I'm going to put this under here so you can kind of see this quickly. For example, okay, ignore my picture for a second. If this is my airplane traveling, if I have a wind and my wind is coming this direction, it's going to push the airplane, and the airplane's going to try to go here, right? So instead of going straight like I want, it's going to try to push me down. And depending on the amount of wind, it's going to depend on how far I'm tilted. Do y'all see what I'm saying? Or maybe the wind might come from the bottom, okay, or from this direction, from the south, and it's going to, depending on which way I'm flying, but just here, it push my line up. Are y'all visually seeing that? So no longer is this line you just drew necessarily true if there's wind. So what they're going to give us is information about the wind. And the info they gave us is that it's blowing from the northwest at 40. This is the reason I was telling you this problem is taking so long. It's because I'm explaining every single little baby step. And after you do a couple, I won't have to explain this all the time. Okay? So they get much faster. So if you're going from the northwest at 40, so what I've told my kids to do earlier is just take another, just to make it simple, let's put in another compass rose there. Okay, you're going to put another one in. Okay? So when you put this in, it's saying, all right, so here's my new section of direction. I didn't mean to rhyme there. But you're going northwest at 40. If this is your map, north, south, west, and east, and I'm going northwest, I'm coming from the northwest. So if I'm going from the northwest, this is northwest, isn't it? There's north, okay, and there's west, that's northwest. So if I'm going from the northwest, your line is going to go, their wind is going to be here. Do you see that? Yeah? I'm going from the northwest. Here's the northwest. Your wind is blowing. Your wind is blowing this direction. So here it is. Here's your airplane trying to fly this way. My wind is going to do what to that orange line right there. It's gonna push it down. You see it? If I'm here, this is this orange line, and I've got a wind tilting, here it's gonna push it down. You see what I'm talking about? So, I don't know that it'll work with another color that you can see it, but, so instead of my airplane traveling here, my airplane's gonna now travel here. That's the new line, that pink line. Y'all can dash it if you want. This dashed line. Okay, this is the your new line that you're gonna try to find. So I know my airplane is 700. I know the wind is traveling at 40. So this right here is 40. Okay, from here to here. What would this angle right here be, guys? If you've got a wind and it cuts northwest, what do you think the angle from here to here is? Don't make it more complicated, like just by glancing at it. What angle is that? Because I'm gonna need an angle.
45.
I heard it.
45.
45. So this angle is 45, which I don't have a lot of room, so I'm gonna bring that triangle down so you can see it bigger. So this is the triangle that I have. I'm this direction, which is 700. The wind is blowing this way at 45. No, I'm sorry, at 40. Okay, which creates me a new path for my airplane called X. We don't know the path. And what did we decide that this was? 40 what? 45. Now, using the information that we studied from the problem I just did before, can I find X? If I've got a side, an angle, and a side, can I find X? Absolutely. Okay, so to find X, we know that X squared equals, when we take the two sides, 700 squared plus your 40 squared, minus 2 times 700 times 40, and then cosine of your 45 degrees. So in your calculator, find me X. Find me how fast the airplane is going. The wind either slowed it down or sped it up. You've got to make that decision. Okay, so X squared is a huge number. Take the square root of it and you should get 672.31 miles per hour. So did your airplane speed up or slow down? Slow down. Okay, so you found the resulting speed. What else did it ask you to find? The what?
Heading.
The heading. The angle. Bless you. Do you remember I drew this picture, and this is the reason why. When I was drawing this picture and I was trying to tell you that an angle was, they would call this plane moving at 90 degrees, no, 100. That's the reason I went into that, okay? Because now I know what X is. So I'm gonna erase this X. And you can use this picture up here, it just was kind of small. So I'm gonna erase the X, and this distance or speed is now 672.31. Okay, I'm gonna use a highlighter for just a second. Okay, look up here so you see me draw. Here's the problem. The airplane was heading this way. You see how I do the yellow line? Okay, watch so you'll understand this. Because of the wind, it's now heading this direction, right? When I was heading west, I would have been traveling how much? From north all the way to west, how many degrees? From north all the way to west? 270, right? I was traveling at 270, but I ended up being back down a little, okay? And what I was back down at, you get a different color. Which you can't see too well. Let me use this. What I was back down at, I was going from here to here, which would have been considered 270 degrees. Okay, but I didn't go that route anymore. The airplane's not traveling that route. It's actually gonna go from here and stop there, right? Okay, so if it's gonna stop at this spot, then I need to find out how much it backed up. How are you gonna find out how much it backed up? By finding what? Yeah, by finding this angle right here, which in this picture is this angle right here. Okay? Well, if you have this side, the 700, and you have the 672, can you find that angle using law of cosine? Yeah, and remember, if you start with law of cosine, you gotta stay with law of cosine. So I'm gonna use those two pieces of information to find my angle, okay, which we already know how to do. So you're gonna take this, you're looking for this angle, okay, and you're gonna take these two pieces of information. So the angle and the 40 go together. So 40 squared equals the two sides that are around it, which is 700 plus 672.31 squared, minus 2 times both of those numbers, and then cosine of my missing angle, and I'll call it y. Okay, do you guys remember how to find this? We've done this before. Do y'all remember how to find it? Yeah, okay, ready? Get your calculators out, because you don't want to mess up because you couldn't do the math on your calculator. All right, here we go. Type in 40 squared. You got it? Remember, we're going to subtract 2 times. So minus 700 squared. And then minus, you're going to minus the 700 and minus the 672.31 squared. And what are you going to hit? Enter. Then what are you going to do? Do y'all remember? You're going to divide by these 3. So divide by -2, divide by 700, and divide by 672.31, then hit enter again. Yep, and when you get it, you're going to take the inverse of that answer. So you take the inverse cosine of your answer. So do inverse cosine answer and hit enter again. And how many? It's tiny. Because remember, just push it down a little. How much did it push it down? 2.41. You guys are doing great. Okay, so you pushed it down 2.41. Okay, but is 2.41 the heading of the airplane? Am I going 2.41 degrees from the north? No. Okay, I was going from here all the way to 270. And how much did I back up? I was at 270, and I backed up that answer, so minus 2.41. Did y'all see it? Okay. So take 240 and subtract 2.41. Thank you. Sorry. 270 minus 2.41. Okay, and you get 267.59 degrees. That's, so you have an airplane traveling 672 miles per hour at 267 degrees from north. Okay? Kind of strange, I know. Right, let's go to number 2. Ask me again.
How do you write the answer?
I did. It asks for the speed. There's the speed. Okay, and it asks for the heading, and the heading is 267 degrees.
Can we write it with the time?
No, there's no time.
No.
Like you did before. No, I want it just like this.
Okay.
Yeah.
Just starting about it. So, are you starting from the north and going that way to 270, but why do you go all the way around that way instead of just going from north?
Because everything is done from due north. She's asking why I didn't just go this way. Okay, all direction is from due north. So if I was theoretically going north, every angle is going to be from there. So if I'm going to go here, I would be 90. If I'm going south, they're going to consider that 180. If I'm going exactly west, they're going to consider that 270. So I was going 270 and I backed up 2 degrees, so that's 270 minus 2. And then we'll do another one and it'll get better. Okay. All right, number 2. Now, it's going to be a little bit easier because I've done one. I don't have to explain as much, all right? So let's try the next one. I'll give you a second to read the problem. My daughter is really sick. Okay, a twin-engine plane leaves Hooks Airport and travels 120 miles in the southeast southeast direction. Alright, so let's worry about the airplane speed right now. So here's my compass rose, or whatever you want to call it, okay, that we're traveling on. And it says I'm going to travel 120 miles in southeast. Okay, you try to map the airplane for me. Southeast. What's your line? It's going southeast. Not from the southeast, it's going towards the southeast. So your airplane would be like right here, right? There's east and there's south, so right here. And it's 120 miles per hour, and speed is the same as the length. So we're gonna label this as 120. Now we have to take into account for the wind. So I'm gonna draw a new compass rose so I can draw the wind accurately. When you draw your new compass rose, guys, make it perfect or it's confusing. And let me explain what I mean by that. Okay, at this point, my plane is going here and I'm stopping. That's how long it is, right? And at the bottom, we're gonna adjust for the wind. So at the bottom of this, draw yourself a new compass rose, and your airplane should land right at its intersection, which you do a perfect job. Right at the intersection of it. Okay, and that's your new compass rose, right? Because I want wind to come from there. The wind that's traveling is traveling in 35 miles an hour. So 35 miles an hour, and this is to me what's strange, from the east. Okay, look at your picture. Let me draw the directions again. North, south. If I'm coming from the east, which way am I going, technically? Look at your paper. Here's your pencil or whatever. Here's the east. If I'm coming from the east, which way am I going actually? Towards the west. Yeah. Why they didn't say I'm going towards the west, I don't know. But if I'm coming from the east, if your wind is blowing from the east, I'm coming from the east, so which way am I actually going? You're going west. Okay? If I'm coming from this way, I'm traveling actually which direction? West. Look at your compass rose. From the east is sending me west. So I'm actually traveling west 35. So I'm going to put this here, and it gave me the speed, which means it gave me the distance. This is 35. Okay, now I want to show you something for a second. If this was your airplane, this is a visual. This is an airplane. I was traveling here. I had wind push me here. My new path is going to be adjusted, isn't it? Y'all see that? Here was my airplane, and I have wind coming from the east, so it's coming this way. It's going to push my airplane down, right? So this is no longer where my airplane is traveling. The airplane is now traveling here, which is creating what figure every time? It did it last time. What figure is it making us? A triangle. Okay, and I'm gonna draw that triangle down here just because I think it helps. So here's the triangle that it's giving us. It's telling us this is 120, it's telling us this is 35, and I'm looking for the new speed of the airplane. I'm looking for that yellow line right here. Okay, I have to have an angle. Okay, I don't know its direction, so I don't know this angle up here. But I do know that if this line intersects this line, because this was going southeast and this was going west, what angle do you think this would be? What kind of angle?
45.
Just like before, it's 45. So this is 45. So it didn't have a lot of room to write. That's 45 right there. Okay, now use your law of cosine to find the missing side. So I want to find x, so x squared, which is the speed of the airplane. That's what we're looking for. We're looking for this little distance right here, which is the speed of the airplane, equals the other two sides, 120 plus 35 squared. I'm sorry, there should be 2's. Minus 2 times 120 times 35 is cosine of your y, of 45, I'm sorry. Remember, this angle and this side go together, so x and 45 go together. Type just the right side in your calculator and take the square root.
39. Where'd you get 45 from?
Okay, how'd I get 45 here?
Mm-hmm.
If this wind is blowing exactly southeast,
Then it
okay,
would
it's
be-
blowing at a 45-degree angle.
Okay, so 90. Okay.
You see half of that, right between east and south is 45 degrees. That's a good question.
Thank you.
What did y'all get for X? Thank you. So the plane is now traveling here at 98.41 miles per hour. Okay, now, look guys, erase this then for me a second, okay? Put in the speed of this plane right here, 98.41, goes right there. And we just have one small part left. I know how fast the plane is going. I now know that this yellow line represents approximately 98, correct? But what I'm asking for now is the direction of the airplane. Remember, it's from the north, so the airplane is now the yellow line. So I'm gonna go from here all the way to the yellow line. Okay? So let's find that angle. All right, and guys, we'll finish tomorrow, okay? We don't have time to finish.